Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to use the Count 5 method to perform hypothesis testing for two population standard deviations, or variances. Let's get started. So we have some alternative approaches to this F-test that's based on the F distribution for testing claims about two standard deviations or variances. And the reason why we want to come up with these alternative approaches is because the F-test is extremely sensitive to departures from normality. So if you don't have normally distributed data and you're using that F-test, it's going to really give you some screwy results. So we want to come up with a test method that can accommodate departures from normality in our data. And one of the common methods that's in use to accommodate that is the Count 5 method. Okay. Why is it called the Count 5 method? Well, because the number 5 shows up quite a bit here in the method. There's 5 steps to the method for one, and for another, the number 5 tends to be the critical value that we select for the method. So, there's different ways that people talk about this and describe it, but I'm going to give you the lowdown here and take you step by step through the method so that you can understand how to use it to test the hypothesis testing. Okay. Now, some people say that there's this requirement that the sample sizes need to be equal. That's not actually essential, but the method is actually a bit more involved than some people let on. Again, I'm going to run you through the steps here one at a time, and we're going to slowly walk through this so you can understand this Count 5 method. So to start off with, our first step is to create the hypotheses. So the null hypothesis will always be the same. We're going to say that the variances are equal to each other because that's what null hypothesis is, a statement of equality. Then our alternative hypothesis is going to typically be the same as well, only it's going to be the complement of that. So we're going to say that our variances are not equal to each other. And this is pretty standard when you're using the Count 5 method. So your hypotheses are pretty much fixed. The next step is to find the mean absolute deviation for each data value x in the sample. And the way we do that is by applying a data transformation that you see here. So the mean absolute deviation, or MAD, get your MAD on, calculate the mean absolute deviation. And this is how we do it. We take each individual data value, subtract from it the mean value, and then take the absolute value of that difference. So we're going to transform our data that way. And this is best done using a spreadsheet like Excel. I mean, you can do it in StatCrunch. It's a little clunky in StatCrunch, as we've seen before when we were looking at data transformations. So typically with the Count 5 method, I like to just put the data in Excel because I can manipulate the data and do the data transformations much easier in Excel. But if you want to use StatCrunch for this, I mean, have at it. So we transform the data set just as we got done talking about. So here's an example of a data set. We've got X and Y variables that we were given, and we're going to transform those data values. So to get the MADs for my X variables, get MAD, get the mean absolute deviation. Sorry, I just can't resist. So here's the first value for my X column. And notice the function that I'm putting up here in the cell. So I'm taking the absolute value of the difference between this value here, which is B2, and then B12 is this value down here. It's the mean value. So the first thing I do is get the mean value for my column. And this is just using the average function for this column of values here. And then you put in the dollar signs. What that does is it keeps that cell fixed the cell reference is fixed, so that when you copy the formula down to other cells, this value doesn't change. So, and that's what we want. We want to keep subtracting the same mean value from all of these individual values. So That's why the dollar signs are there. So we just copy that down here. We're going to do the same thing with the y's. When we're using the mean value for the y values here. And so now we've got all of our mean average, mean absolute deviation, or MADs, for each of our data values in our set. So now we've transformed the data set. The next step that we're going to have is to find our test statistics. So now we have our transformed data. Now we're ready to find our test statistics. And there's two test statistics that we're looking at. So the first one, which is called C1, is going to be the number of MAD1 values that are greater than the maximum MAD2 value. And then you just flip that around to get the second test statistic. C2 is going to be the number of MAD2 values that are greater than the maximum MAD1 values. So again, it's much easier to do this in Excel than it is in StatCrunch. So going back to what we had before, looking at our example data here in Excel, so now what I've done is I've actually calculated the maximum function. And notice it's just a max function for that column of data. So Excel can actually pick that out really easy for me. I don't have to squint my eyes and look to see what that is. So I've got the maximum MAD value for both the X and the Y values listed down here. And now the next step is just going to be doing a comparison. So I look and see how many of these values here in this column are greater than this MAD max value here. Well, if you look, you're going to see that none of them are. None of them are greater than 0.03356. So therefore, C1 is going to be equal to 0. I then switch it around and do the same thing with the other side. So how many of these values here, okay, are going to be greater than this MAD max value here? Okay, and if you look, you can see there's two of them, and they're right here. So you've got 0.024 and 0.033 that are going to be greater than the 0.019. The rest of them are less. So we've got two values that are greater. Therefore, C2 is going to be equal to 2. So now we've got our test statistics. We can move on to the next step of the Count 5 method, which is to find the critical value. There's two ways this can work out. If we have equal sample sizes, like we do in this example, the critical value is just going to be 5. If the sample values are not equal, then we have to use this monstrosity of an expression to calculate the critical value. Fortunately for us, our critical values is going to be 5 because our sample sizes are the same. So there's no need to use that monstrous expression to calculate the critical value. And then the last step is we conclude our hypothesis test. So we're going to compare the critical value with our test statistics. This can come out one of three ways. The first way is if C1 is greater than or equal to the critical value. So we test that. C1 is going to be 0 in our case. Is that greater than the critical value? Well, no. 0 is less than 5. 5 is our critical value. So no, it's not going to come out that way. So we're not going to reject the null hypothesis in favor of the first sample variance being greater than the second sample variance. Could flip that around and say, well, if the second test statistic is greater than the critical value, then we reject it in favor of the other way. Well, we can test that as well. C2 is equal to 2, as we saw. Is that greater than the critical value? Well, no, 2 is not greater than 5. Therefore, we're not going to reject the null hypothesis in favor of the first sample variance being less than the second sample variance. The only other way this can come out then is if both of those test statistics are less than the critical value, then we fail to reject the null hypothesis. And that's what we have here, because both of our test statistics are less than our critical value. So then we fail to reject the null hypothesis. Again, a little convoluted method, but it accommodates departures for normality in your data. And so that's really all there is to the Count 5 method. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.